Okay, so this is a new thing I'm going to try on the iPad, is just a screen recording. So these are the notes that we're going to take on Monday in class, but you could go ahead and get a head start and write them down if you want, or you can just listen to me talk through the 3 examples. So the property of equality for exponential functions is written right here. If b to the x power equals b to the y power, then x equals y. So notice if they have what we call a like base, they both had the same base, then we're allowed to sort of cancel those out and set the exponents equal to each other. So then another example would be if we have 3 to the x power equals 3 to the 5th power. We're allowed to cancel out the base because it's the same, and we would say that x is simply equal to 5. Alright, so let's look at these 3 more examples of this type of exponential equation. We're given 2 to the x equals 8 to the 3rd. We can rewrite the 8 as 2 cubed, because that's equivalent to 8. And then it still has a power of 3. So in our first step, we just rewrote the 8 as 2 cubed, and then we are allowed to simplify. So 2 to the x would equal 2, and then we multiply the 3's together to get 9. And now you can see they have a like base of 2, so we're able to just cancel those out and say that x equals 9. And that would be our solution. For example B, we're given 9 to the 2x minus 1 power equals 3 to the 6x power. So you look at your bases and think, can I make those the same base? And I can, because 9 is equivalent to 3 squared. So I simply rewrite the 9 as 3 squared, keeping the exponent of 2x minus 1. 3 to the 6x power is on the other side. So now you just have to simplify a little bit and distribute that 2 to the 2x minus 1. So you get 3 to the 4x minus 2 power equals 3 to the 6x power. So now that they have a like base of 3, you can cancel them out. And you can set the exponents equal to each other. So we just have a little more work to do to solve 4x minus 2 is equal to 6x. So if we subtract 4x on both sides, we get negative 2 is equal to 2x. And then if we divide by 2, we get negative 1 is equal to x. So then we're finished with example B. So let's look at one more example of this, and then we'll do some more in class tomorrow. So we have 5 to the 5x power is equal to 125 to the x plus 2 power. So 5 to the 5x, the 5 as that base can't really be written as anything other than 5, but 125 could be rewritten as 5 cubed. So let's rewrite it as 5 cubed, keeping the x plus 2. Then you just have to distribute the 3, so you end up with 3x plus 6. And keep the left side the same for now. So now you have a like base of 5, and you can cancel those out, and you can bring down what's left in the exponent. So I just brought 5x is equal to 3x plus 6 down, and now we just have to solve that equation. So we could subtract 3x from both sides and get 2x equals 6. Then divide both sides by 2, and we just get x equals 3. Okay, so we'll work on that some more in class tomorrow.